Kia ora, I'm Madeline Newman of the AI Forum Aotearoa New Zealand, and I'm joined today by David Rajan. David's career spans technology, data, product design, and business strategy. He is passionate about designing and building new products, services, and businesses, with past projects including things like Centaur Robotics, which is creating superhuman technology to reimagine mobility for people. Today, he is the CEO of Opteran, a brain biomimicry company. I'm going to get that right eventually. Re-engineering insect brains onto silicone with the purpose of enabling machines to move autonomously, just like insects do in nature. Hi, David. Welcome.
Hi, Madeline. Nice to talk to you.
Great. So for the New Zealand audience, can you just give us a quick overview of bees' brains, how you're using them in natural intelligence and why that's important?
Yeah, sure. Well, I think when it comes to autonomy, really for us, the true example of it is quite simply, if you just look out of your window, you'll see bees, birds, nature already solved autonomy. And it's not computer scientists doing statistical pattern matching in a data center on petabytes of data and thousands of servers. Real brains solved autonomy over millennia, eons. And what we do at Opteran is to go inside a brain, and we've chosen insects because a lot of the core functionality, you could say, of seeing the world, sensing it, moving, navigating, making decisions, is available to us in brains that are like a honeybee, about 1 million neurons, size of a pinhead. And if you can understand that, it's a heck of a lot easier than trying to figure out how a human brain does it with 86 billion neurons in it. And so insects are really good sources of understanding the fundamentals of autonomy. And we, for us, after a decade's research, it's borne fruit.
Fantastic. So what you've developed then is a bit of a world's first, and Opteran is well on its way to being a unicorn. Who came up with the idea, and how have you turned it into something that you could bring to market?
Yeah, so I have two co-founders, Professor James Marshall and Dr. Alex Cope. James is our Chief Scientific Officer and Alex is our CTO. I mean, really, they're the brains, you could say, behind the business. I was brought on to really spin it out of the University of Sheffield and commercialize the company, raise the funds and so on. But James really responded to a European Union project called the Human Brain Project with IBM. It was set up about 10 or 15 years ago to map the human brain. And he had a really strong, quite visceral reaction to this. He thought it was one of the most stupid ideas he'd ever heard of. As I mentioned, the human brain's got 86 billion neurons. And he thought, well, if you're ever going to try and do something as complicated as understand a brain, don't pick one of the hardest to start on. And so he asked himself, what would I do? And he said, well, I'd probably pick an insect. He thought, well, maybe fruit flies, but they don't really do very much. Whereas honeybees and ants, especially honeybees, navigate over a 10-kilometer radius dynamically. They remember locations and go back to them weeks and days later. They can communicate locations to other bees in the hive. They're amazing autonomous machines. And he felt that was, if he could do that, he had an outside chance of achieving it. And if he did it, it'd be worthwhile. And that's really what was the genesis of the company. And he and Alex spent about a decade doing research funded by the UK government and achieved it.
Fantastic. Hey, in New Zealand, we think about AI use cases to save the environment. Like, for example, we're using facial recognition technology and AI to identify individual dolphins in order to manage their interaction with fishing fleets. And that's part of the Maui 63 Dolphin Project. But you've taken something from nature, or from the natural world rather, to benefit technology. Are there other things in the environment that we could utilize to develop beneficial technologies like that?
Well, you're absolutely right. I mean, we are a form of field known as biomimicry. A lot of people do biomimicry. It's an emerging science and field. We are pioneers of something we call brain biomimicry, where we re-engineer the structure and function of actual brains. So from a green perspective, we don't gather data at all. It's edge only, innate behavior on a machine. The data in an AI model tends to be petabytes of data gathered from a plethora of sensors into a data center. And then you train a neural net to learn things. Now the CO2 of training a single neuron in a single neural network in a data center is nearly 9 times higher than the CO2 of our whole company, because we don't have all those servers storing data whirring away. We go straight from brain into software, which we put on low-end silicon. And so really, that's come from nature. You know, nature has solved so many things over many years. It's taken weird forks, strange answers to answer questions. For example, in some of our stuff, there's some weird filter. It's just really weird filter in the way that it does something. And you know, we would never second guess that if we were trying to code it in a million years. Nature figured it out through evolution, and it solves a problem really efficiently. And so really, we'd argue it's a great idea to go and look at nature, but it's not unique. We're not unique in doing that. We are pioneers, as you say, and unique in brain biomimicry. But there are other companies doing this in research programs in this field. One of the ones I love is Dragonfly. A company built a very small drone that has 4 wings that flap. And the reason is, in high wind, rotor-driven drones are very unstable, but Dragonfly has evolved with very capable high stability in high wind. And so this drone is incredibly stable in high wind. I've also seen fins for boats, looking at like animal fins to propel boats instead of the traditional blades you see on a motorboat. There's lots of things out there people are doing. Even to the physiology, I've seen people actually there's a Harvard project where they're actually building bees. They're incredibly tiny and they flap and fly. It's a bit Black Mirror, but it's really incredible and basically copying nature, really.
Fantastic. Hey, how do you see these kinds of insect-driven technologies growing over time? I'm thinking especially sort of, you did a link up with those Centaur robots or robotics, sorry, that we talked about earlier.
Yeah, I mean, we haven't done nothing with Centaur yet. They're still at an earlier stage of. I mean, that's a self-balancing a machine that could be autonomous. I mean, it's trying to reinvent the powered wheelchair to give really create a product that's got some dignity that actually people want to be in if they have some mobility issue, as opposed to the more like Victorian rattan bath chairs that people get today. And we would like to make that machine autonomous at the right time. And I think for us, you know, what we have is so small and lightweight. We use a pair of 2D CMOS cameras that cost about $20. And so for a machine like that, that's really price sensitive in the consumer market, to add autonomy with hardware at a level that we can give them is really opens up the market for them. And we're finding a lot of companies like that. You know, we're working with another US security firm that want to do indoor drone-based autonomy. And the current systems and paradigms are so expensive. The hardware is so expensive that it's very difficult to actually open up the market opportunity to them. And they know their market. They've got millions of customers. And if they can get the hardware down to do autonomy at a price point, a J curve happens that makes it an incredibly material market. But the challenge is getting systems to be very capable at being autonomous on very low swaps, and that's a real challenge today.
Exactly. So just one last point for you, David, and I'll let you get back to your busy life. Opteran, what's next?
What's next? I always say it's pretty simple. I mean, we're doing some pretty amazing science and building some pretty incredible technology. But at the end of the day, it's a market stall in some way, almost like a medieval market stall. What's next for us? We have to build a differentiated product that people would see value in and want to spend money on. To some degree, yeah, it's deep science and incredible, but it could be lamb chops. So for us, it's just about building absolutely great, differentiated, compelling product and working with customers to help them build amazing autonomous systems. And the journey for us is really that. But I think to give a little bit of a more exciting spin on it, than lamb chops, although I love a lamb chop, we have, brains evolved initially when animals started to move. There are even examples of creatures essentially eating their own brains or de-evolving a brain when they stop moving. You only need a brain when you move to ask all the hard questions. Well, why should I move there? When I get there, what am I going to do? Is that thing coming towards me or I'm moving towards dangerous? Do I touch it? Do I run away from it? Do I eat it? So all the cognitive intelligence in animals evolved with movement. And we've done all the movement stuff in our systems. We've nailed low memory, low swaps, natural autonomy, not rigid automatons, allowing machines to move around like natural creatures in unstructured environments with different lighting conditions, indoors and outdoors, in highly dynamic environments, moving around in the way you would around maybe a conference center or something like that, fluidly. But what we've got working in the lab, and this is a little bit of a secret in a way, but we have natural brain decision making. So this is not reinforcement learning on data, and it is not condition statements, large condition trees of this, then, that type statements. This is the algorithms taken from real brains that allow machines to fulfill motivations they have and prioritize tasks and activities and switch tasks without dithering and deadlock. And we have that working. That's going to be coming out next year. So our first product this year is the Opteran, really the cognitive ability to move around spatially. Next year, we have the cognitive capability to make decisions dynamically. And we've also recently, over the last few months, implemented, again, this is in the lab, I should say, not yet in product, one-shot image recognition. And so we can take, we're using the MNES data set like everybody does, but today people are training on 30, 50,000 handwritten images of numbers to train a neural net. We can show our system, I don't know, pick a number 6, say, handwritten number 6, and then show it another handwritten number 6, and it will recognize it. And that is one-shot image recognition, and that is pretty incredible. And so, our systems do not need training. They learn innately like a natural creature. There's no training going on. And I think that's the future for us. It's building these higher order cognitive functions. We can see the world, we can sense it, we can move around it, but making decisions, recognizing objects, learning, cause and effect, things like this are what we're doing. We're on a path to this whole thing that people talk about, general intelligence. Well, we call it natural general intelligence or general natural intelligence. But the idea being that there's so much to mine in nature from brains that we can build systems that are more like the C3PO that we dream of as children in terms of robotics. Fluid, natural creatures that can move around without human control or systems over them, as opposed to rigid automatons. And that's the dream for us.
Fantastic. Hey, thank you so much, David, for joining us today. And best of luck for the future.
Thanks, Madeline. It's lovely to talk to you.